quick comment about the comparison test, and that is that what we've done so far is use find a sequence bk such that ak is less than bk, and if bk converges then ak converges, essentially. Okay, that's a informal way of stating it. If you learn anything about logical statements in mathematics or in general, you know the contrapositive of a statement has the same logical value as the statement itself. So that statement's true that if bk is greater than ak and bk converges, then ak converges. So the contrapositive of that is if we still have a bk, or if we have an ak less than bk and ak diverges, then bk diverges. So that's one way you can use the test. If you want to show a sequence, a series diverges, you can find a sequence such that all the terms in that sequence are less than the terms in the sequence you want to show diverges. And if that smaller sequence, if the series of that sequence, if the sum of that sequence diverges, so does the sum of your sequence bk. Okay, so that's just my quick comment on that, and we'll move on to a new test, and this is not related to that previous test, so that's fine, but I just wanted to make that comment. Suppose that AK and BK are positive for K greater than or equal to B. And this just means that the terms in the sequence are all positive terms. Right. When K is greater than or equal to B, so, and that the limit L equal the limit as K tends to infinity of AK over BK exists and is finite. So if, as the terms in the sequence of AK, if K goes to infinity, if AK over BK tends to some real number L, some finite real number, then the series is sum from K equals P up to infinity of AK, and you guessed it, the sum from K equals P up to infinity of BK behave the same, so they either both converge or both diverge. Okay, so that's quite a nice result. So what we're considering with this limit is, this is the limit of the quotient of the sequences. Okay, so remember AK and BK are sequences, so AK might be defined by 4K plus 2. Like that's just an example. Okay. Whereas this sum here would be the sum from K equals P up to infinity of 4K plus 2. Okay, so that would be 4P plus 2 plus 4P plus 1 plus 2, so on. And similarly for BK. So we can consider this limit of the sequences, and that gives us some information about the series. And that's nice, because if we want to know if, say, this converges or diverges, and we know the behavior of another series BK, and we want to see then if we can find this limit, then we know they both do the same, and if we know what this does, then we know what AK does. Okay, so that's where this result can come in handy. I might look at some examples of this in a future video if I can find a nice example, because I think it is quite a simple result, and we'll move on to some more results in the future. If you have any questions about this, let me know down in the comments below. If you did enjoy this video, please be sure to like and subscribe, and I hope to see you in the next one.